Okay, so the next thing that we have here is another theorem, which is of course very useful in, which is basically the limit of some rational function, which is very useful in taking derivatives or calculating the derivatives of functions. And that is basically the theorem is basically goes like this. So theorem 2, you say that for any positive integer n, for any positive integer n, the limit of x raised to the power n minus a raised to the power n over x minus a, when x tends to a, is equal to n times a raised to the power n minus 1. So that is basically the theorem. Now of course we need to prove this. And as a remark, it says that the expression in the above theorem for the limit, that this expression is true even if n is any rational number and a is positive. So it says that basically the theorem is true. Basically, I could say that the theorem 2 is true. Theorem 2 is true for even if n is any rational number and a is positive. Now the reason it says that a has to be positive and n is any rational number. Okay, so let's see how that works out. Basically, in order to understand basically why, how this limit works, you need to take a look at the proof of the theorem, see basically see how it's been proved, and then based on that we can basically decide other things. So now the theorem is basically, as you know, is that the limit of x raised to the power n minus a raised to the power n over x minus a, and you want to calculate the limit of this when x tends to a, and you want to know what that is. So if I divide x raised to the power n minus a raised to the power n by this expression, what I will get is, suppose that I have x raised to the power n minus a raised to the power n, and if I divide it by x minus a, if you do this division, what you will get is that x raised to the power n divided by x is basically x raised to the power n minus 1. Because x raised to the power n minus 1, x raised to the power n minus 1 times x is equal to x raised to the power n minus 1 plus 1, which is equal to x raised to the power n, which is equal to x raised to the power n. So this is x raised to the power n minus 1. So then if I multiply x raised to the power n minus 1 by x, I will get x raised to the power n minus 8 times x raised to the power n minus 1. Now if I subtract negative positive. So then if you cancel these two out, you will get basically negative you will get a times x raised to the power n minus 1 minus a raised to the power n minus a raised to the power n. Now again, if you divide a times x raised to the power n minus 1, if you divide it by x, what you will get is basically plus a times x raised to the power n minus 2. So a times x raised to the power n minus 2 times x is going to be 8 times x raised to the power n minus 1. And then a times x raised to the power n minus 2 times negative a is going to be negative a squared x raised to the power n minus 2. Now if I subtract, I will get negative positive, and then subtract, these two will be cancelled out, and then you have a squared x raised to the power n minus 2 minus a raised to the power n. Again, if you divide, for example, a squared x raised to the power n minus 2 by x, you will get plus a squared x raised to the power n minus 3. X raised to the power n minus 3 times x is going to be equal to x raised to the power n minus 2, and then you have an a squared over here. So this gives you a squared x raised to the power n minus 2, and then this part over here gives you basically negative a cube x raised to the power n minus 3. And so if you negative positive, if you subtract, these two will be cancelled out, and then you will have a cube x raised to the power n minus 3 minus n a raised to the power n. And so as you can see, over here you start with x raised to the power n minus 1 plus a times x raised to the power n minus 2, a squared x raised to the power n minus 3, and okay, so let me see. Okay, so as you can see here, this is basically starting with basically x raised to the power n minus 1, then you get a raised to the power a times x raised to the power n minus 2, then a squared x raised to the power n minus 3. So this just keeps going. So you can write this quotient, you can write it as basically x raised to the power n minus 1 and plus a times, or you can write this as x raised to the power n minus 2 times a as x raised to the power n minus 3 times a squared plus all the way up to, so you see that basically over here you can go all the way up to x raised to the power n minus n, which is basically x raised to the power 0. So x raised to the power n minus n, and so a raised to the power times a raised to the power n minus 1. And so the term that comes before this would therefore would therefore be x raised to the power n minus 1 for n minus a raised to the power, or x raised to the power basically n minus 1, this is x raised to the power 0, so this would be x raised to the power 1, and a raised to the power n minus 2, for example. A raised to the power n minus 2. So then this quotient becomes x raised to the power n minus 1 plus x raised to the power plus x raised to the power n minus 2 times a plus x raised to the power n minus 3 times a squared, all the way up to x times a raised to the power n minus 2 plus x times n raised to the power n, which is equal to 1. So we can write this as just 1, a raised to the power n minus 1. So you can just simply forget about this part. You can just simply forget about this part. So this is going to be your quotient. What that means is that if you divide x raised to the power n minus a raised to the power n, if you divide x raised to the power n by a raised to the power n by x, if you divide x raised to the power n minus a raised to the power n by this, you will get basically this quotient over here. Or you can write basically x raised to the power n, you can write x raised to the power n minus a raised to the power n as basically the product of this and this quotient over here. So this is x minus a, this is x minus a times basically this whole thing over here, which is x raised to the power n minus x raised to the power n minus 1 plus x raised to the power n minus 2 times a plus x raised to the power n minus 3 times a squared plus all the way up to x times a raised to the power n minus 2 plus a raised to the power n minus 1. So that is basically how you can write this. Now, so what that means is that, of course, the quotient is going to be this thing over here, and the limit that we had was the limit of x raised to the power n minus a raised to the power n over x minus a when x tends to a, and this basically this quotient is basically this thing over here. So you can write it as the limit of x raised to the power n minus 1 plus x raised to the power n minus 2 times a plus x raised to the power n minus 3 times a squared plus all the way up to x times a raised to the power n minus 2 plus a times a raised to the power n minus 1. The limit of this as x tends to a. So this is a polynomial, of course. This is a polynomial, and of course, to get the limit of this polynomial, you have to basically calculate the value of this polynomial at x is equal to 8, which becomes basically a raised to the power n minus 1 plus 8 raised to the power n minus 2 times a plus a raised to the power n minus 3 times a squared plus all the way up to a times a raised to the power n minus 2 plus a raised to the power n minus 1, which is of course equal to a raised to the power n minus 1, and a raised to the power n minus 2 times a is equal to a raised to the power n minus 1. And again over here you have a raised to the power n minus 1 plus all the way up to a raised to the power n minus 1 plus a raised to the power n minus 1, and that happens basically for n terms. That happens for n terms. That means that the sum of all this is going to be n times a raised to the power n minus 1. So So what that means is that the limit of x raised to the power n minus a raised to the power n over x minus a is, when x tends to a, is equal to n times a raised to the power n minus 1. And here basically n is a positive integer. N is a positive integer and a is supposed to be positive. And the reason for that is that I think lies with polynomials, because we say that, because in a polynomial we say that f of x is equal to a of 0 plus a of 1 x raised to the power 1 plus a of 2 x raised to the power 2 plus all the way up to a of n x raised to the power n. Now, of course, over here, a0, a1, a2, a3 can be any real number. It could be any positive or negative. But these basically, n has to be a positive integer. So, so that means that's the explanation for n over here, which has to be a positive integer. And now if a is a negative number, for example, suppose that for example a is equal to negative 2. Now if a is equal to negative 2, what happens is that you have basically I don't really know why a has to be a positive number. I don't really know that. Maybe in some example we will find out why a has to be a positive number. We will keep this until we understand it. Okay? Now, as an example, what we have is example number 3. Okay, so for example, suppose that you want to calculate the limit of x raised to the power 15 minus 1, x raised to the power 10 minus 1, when x tends to 1. We want to calculate the limit of this expression. So what happens here is that basically the theorem that we had, we said the limit of x raised to the power n minus a raised to the power n over x minus a, when x tends to a, is equal to 8 times n times a raised to the power n minus 1. This was the theorem that we had. So basically if you want to use this theorem, this expression has to look like this. Otherwise you couldn't use the theorem really. So what you need to do is make some changes to the expression. Okay, so now what I can do here is that I can write this as the limit of x tends to 1 of, then I can write x raised to the power 15 minus 1. Then I can divide this by x minus 1. And then again x raised to the power 10 minus 1. I can divide that by x minus 1. So that basically, that is basically what I want to find the limit of. And since I have divided both the numerator and denominator by the same number or factor, whatever, or expression, I've not changed the expression itself. And so now I can write this as the limit of x tends to 1 of x raised to the power 15 minus 1 over x minus 1, and I can write this as x raised to the power 15 minus 1 raised to the power 15, because 1 raised to the power 15 is equal to 1 actually. So I can write it this way, and write this as the limit of x tends to 1 of x raised to the power 10 minus 1 raised to the power 10 over x minus 1. And so now you can use the theorem in the numerator and also in the denominator, and write this as basically, n times 15 times a, which is 1, raised to the power n minus 1 raised to the power 14. And over here I can write 10 times 1 raised to the power 9, for example, 10 minus 1. So this is equal to 1 and this is equal to 1. So then I have divide by 5, you will get 3, divide by 5, you will get 2, so this is equal to 3 halves. This is equal to 3 halves. Now the next one is a little more interesting, because there is substitution in there. Of course I have done these examples once because I had to come to this point even a little further than this, and then just up to this point, and I came to this point. I had some problem with the concept, so I had to go back and reread everything, and of course the concept of limit and the concept of derivatives and the concept of calculus, basically you do need to understand it. You cannot memorize it, you cannot skip it, you cannot do anything other than understand it, because everything that you need in mathematics, everything that you need in physics, everything that you need in economics, everything that you need in biology, everything that you need in chemistry is all based on calculus. You cannot skip it, and of course you do have to understand it. So the concept is very important, and moreover, one more thing, if you don't understand your basic mathematics, meaning that and what I mean by basic mathematics is basically the mathematics from, let's say, class 6 all the way up to class 10, 11 or so. And what I mean by that is everything in there. Everything that there is, starting from class 6 all the way up to class 11, wherever basically, for example, calculus starts. If you don't understand those concepts properly, very well, then you will not be able to understand calculus. If you don't understand calculus, you will not be able to understand physics and all of the other subjects that I just mentioned. And one more problem is that the world today is based on, well, one of these things. I mean, you have to first of all, of course, the world has changed a little bit, meaning that you need to understand your basic science for your basic life, basically. And then, of course, you do need a speciality to probably earn some money, and that basically all depends on mathematics, really. So that's that. Now the next question that we have is you want to find the limit of the square root of 1 plus x, square root of 1 plus x minus 1 over x, when x tends to 0. Okay, so this is basically, you can rewrite this as, for example, the limit of, for example, 1 plus x raised to the power, for example, 1 by 2 minus 1 over x, and you couldn't do much with this expression. So one way that you can solve this problem is to basically to take 1 plus x as y. You can take 1 plus x as y. So basically taking 1 plus x equal to y. So then you would have basically the square root of y minus 1. So this would be then basically the limit of the square root of y, minus 1, and then x here is, of course, since you've written this part of the expression in terms of y, then you have to write everything in terms of y. So then your x is going to be equal to y minus 1. X is going to be equal to y minus 1. So then instead of x you can write y minus 1. And of course here x tends to 0. Now if x tends to 0, y tends to 1, right? Because x gets very close to 0, so y gets very close to 1. So here you can write y tends to 1. And so here you can write this expression as the limit of y raised to the power 1/2 minus 1 raised to the power 1/2 over y minus 1 when y tends to 1, and the theorem that we had was basically the limit of x raised to the power n minus a raised to the power n over x minus a as x tends to a is equal to n times a raised to the power n minus 1. So then we can write this as n times 1/2 times n raised a 1/2 times a raised to the power n minus 1. So that is basically 1/2 minus 1. Now whatever that is, this is equal to 1. This is equal to 1, so you'll get 1/2 over here. So basically your limit is basically 1/2 over there. Now the next thing that we have on this list is the limit of trigonometric functions. So we will talk about them in the next video. See you in the next video.